Good afternoon, ma'am, and to my fellow investigator. This afternoon, I will present my mathematical investigation and modeling entitled Polyhedron. Here are I'm Mylene Cuizon from the Math major. Here are my objectives. At the end of this activity, the students will be able to describe shapes and solids in terms of vertices, faces, and edges. Second, use critical attributes to define geometric shapes or solids. Number 3, understand how learning may be assessed through the use of mathematics manipulative. So the problem is, how can you predict the number of edges of a polyhedron from the number of vertices and faces? This investigation involves collecting data from as many different polyhedrons as possible to find relationship between their number of vertices, edges, and faces. The starting point of the activity is to ask how you can solve wood to make polyhedron with a given number of faces, for example, cube, tetrahedron, and others. And this is the problem that we can investigate this afternoon. So, these are the problems. First is, consider the number of faces to solve wood in order to make polyhedron. Make connection between polyhedral or polyhedrons and their properties. How would you describe the characteristic of a polyhedron? So, characteristics. Polyhedron surface. So, the three-dimensional body of a polyhedron is made up of several components. So, first one is, the faces are parts of two-dimensional planes, which is, this one is the first characteristic of a polyhedron. The faces, which is meet along the edges, which is one-dimensional straight line segments, and these edges meet at their vertices, which is zero-dimensional. Then a defining characteristic of almost all kinds of polyhedra is just two faces joined along any common edge. So if we connect the polyhedra, we are just connecting two faces to form a polyhedron. Then edges have two important characteristics. So an edge joins just two vertices. So if we are doing a polyhedra, so we have now the faces, its edges are joined two vertices. So faces, then they are joined at two vertices, then only two faces. These two characteristics are dual to each other. Next is the Euler characteristic. So the Euler characteristic relates the number of vertices, which is p, then the number of faces, and the number of edges. That is the Euler characteristic. So, next is the duality. For every polyhedron, there exists a dual polyhedron, having faces in place of the original vertices and vice versa. This is the example of the dual polyhedron. Which is, we can see that there are two pyramids. Pyramid here in the stela octangula, wherein these faces placed on original vertices and vice versa. Then the same number of edges. So as we can see sa the original polyhedra, when we combine them, the same number of their edges, then the same the Euler characteristic also the same. Next is, what are some common polyhedrons? So, common polyhedra are platonic solids, prisms, and pyramids. But the most common polyhedron is the cube, because as we can see, cube has 6 flat faces that are polygons. In that case, all of the faces are square and 12 straight edges. Additionally, a cube has 8 vertices, and which is the corners. So, this is the example of cube. We can see the 12 straight edges. So 1, 2, 3, 4. May flat 5, 6, 7, 8, 9. Yung base is 9, 10, 11, 12. So we have now 12 straight edges. Then 8 vertices. Vertices is 1, 2, 3, 4, 5, 6, 7, 8. Then 6 flat faces, which is polygons, rectangle. 1, 2, 3, 4, then yung I-square, which then the nasa taas is 5, then 6 yung magiging base. Then, how would you describe the faces of tetrahedron, hexahedron, and octahedron? So, tetrahedron. So, this one is tetrahedron.
Easy lang ba yun? Easy lang.
So, this polyhedron is called tetrahedron. So, tetrahedron is a polyhedron composed of 4 triangular faces. So, as we see, we have 4 triangular faces. Then, 3 of which meet at each vertex. So, we have now 3 faces. Then, we can see that each faces meet at each vertex. So, then a regular tetrahedron is one in which the 4 triangles are regular or equilateral. So, to make a tetrahedron, so the triangle we use is equilateral, or they have the sides are equal. Then, and is one of the Platonic solids. The tetrahedron is the only convex polyhedron that has 4 faces. The tetrahedron is one kind of pyramid, which is a polyhedron with a flat polygon base and triangular faces connecting the base to a common point. In that case of a tetrahedron, the base is a triangle. Any of the 4 faces can be considered the base. So, a tetrahedron is also known as a triangular pyramid. So, tetrahedron is also called triangular pyramid because any of the faces of this polyhedron can be base. So this can be a triangular pyramid. Next is hexahedron. So hexahedron is the most common of all polyhedron, which is commonly known as the cube. It has 6 faces which are all square. Each faces is the same size square meet at each corner. So hexahedron is the most common of all polyhedron and commonly known as the cube. Next is the octahedron. Octahedron is a polyhedron with 8 faces. So, this one.